All right, finally getting into Kelvin and absolute zero, lesson 1.11. All right, so absolute zero is the reason why we have the Kelvin system. So you're going to learn how to convert between Celsius and Kelvin, and you're going to be able to describe what happens at absolute zero. So we talked about temperature and motion before. All right, so temperature is defined as a measure of the movement of a molecule in a substance, aka you're measuring the kinetic energy. All right, so the kinetic energy is how much the molecules are moving. So do you remember what happens? What happens to kinetic energy as your temperature increases? So does the kinetic energy go up or down as temperature goes up? Hopefully you're remembering that the hotter you make the molecules, the more they move. So if T goes up, your kinetic energy goes up. So Lord Kelvin, the guy who got the unit named after him, theorized that there is a temperature so low that your molecules stop moving. The kinetic energy drops to zero. All right, and that temperature is defined as absolute zero. All right, and that's what we made 0 Kelvin. All right, so absolute zero is 0 Kelvin. And that is the temperature at which all molecules stop moving. All right, this is a theoretical value. It hasn't been proven yet, but scientists have gotten within a billionth of what they currently think 0 Kelvin would be. All right, but this isn't something you can do very easily, because if all the molecules in the air stopped moving around, or if all the molecules in your body stopped moving around, that wouldn't be good for you. So, what was the temperature where all molecular motion stops? Hopefully you said D. And let's look at another kind of representation of this. All right, so we've got a graph here. Now I want you to decide which graph, A or B, represents the cooler temperature. All right? So we've got a count of number of molecules, and we've got a value for speed. All right? So like these are really fast molecules down here, and these are slow molecules down here. All right, so if you're looking at your blue graph, all right, the peak where most of your blue molecules are is right there. Then if you look at your red graph, the peak where most of your red molecules are is there. All right? So just kind of looking at that, which one's moving faster? All right, B, most of those B molecules are moving faster than the A molecules. All right, so how does speed of a molecule relate to temperature? All right, so if B is faster than A, B is also going to be hotter than A. So the molecules that have the cooler temperature are going to be A. All right, so using this Kelvin temperature scale, it's actually going to be one of the easiest conversions you probably ever deal with. All right, so 0 Kelvin, at least according to what we think right now, is the equivalent of negative 273 degrees Celsius. All right, and it's a linear scale. So that means if you want to calculate Kelvin, so say you're given a Celsius temperature and you want to calculate the Kelvin from that, all you got to do is, so your K is equal to, K is equal to Celsius plus 273. And if you need to calculate Celsius, that means you're going to take your Kelvin and you're going to subtract 273. Easy peasy. Write these down though so you don't forget, because you don't want to accidentally flip it. Another thing is Kelvin should never ever give you a negative value. You should never have a negative Kelvin. We can't get colder than no motion. So let's practice some of these. So we're going to do 273 Kelvin to Celsius. All right. So, woohoo. My screen is freaking out on me. All right, so if we remember, Celsius is equal to Kelvin minus 273. And Kelvin is equal to Celsius plus 273. So this is going to be C equals 273 minus 273, or 0 degrees Celsius. All right, and then here we've got our 25 degrees Celsius to Kelvin. So Kelvin is equal to 25 plus 273. So that's going to be 298. All right, you try the next one. So 456 Kelvin to Celsius. So we're going to have C equals 456 minus 273. And that's, I cannot do in my head right now. That is 183 degrees Celsius. This last one I wanted to show it to you because you're going to see quiz questions that are formulated this way. If you see a question asked for the absolute temperature, all right, absolute temperature is asking you for Kelvin. All right, so it's saying, what is 37 degrees Celsius in Kelvin? So now, calculate it. Hopefully you got 310 Kelvin.